In this video I'd like to show how to calculate the cube root of a number using an old mechanical calculator. Since this isn't directly supported by the machine, I use an interval-based approximation method. The interval is gradually reduced further and further, until we get a good approximation for the result. I'd like to show this for the third root of 3.5375 as an example. For the initial interval we need a number that is smaller than the result we're looking for and one that is greater. 1 to the power of 3 is 1 which is smaller than 3.5375. 2 to the power of 3 is 8, which is greater. The number we are looking for is therefore in the interval from 1 to 2. We now halve the interval and as a first approximation we get 1.5, which is the mean value of the interval limits. Input 1.5. Multiply by 1.5. Return the carriage to the home position with the arrow pointing to 1. The intermediate result 2.25 is then copied from the result unit to the input unit. Reset the counter and the result unit. Multiply by 1.5 again. The result of 1.5 to the power of 3 is 3.375. The number is smaller than our radicand 3.5375. Therefore, 1.5 is the new lower limit of our interval from 1.5 to 2. I use 1.7 as the next approximation. Reset all and move the carriage to the home position at 1. Input 1.7. Multiply by 1.7. The square is 2.89. Move carriage to 1, then copy the intermediate result from the result unit to the input unit. Reset counter and result unit. Multiply by 1.7 again. The result of 1.7 to the power of 3 is 4.913. This is greater than our radicand. Therefore 1.7 is the new upper limit of the interval. The next approximation is 1.6. Reset all and move to 1. Input 1.6. Multiply by 1.6. The square is 2.56. Move to 1 and copy the intermediate result. Reset counter and result unit. Multiply by 1.6 again. 1.6 to the power of 3 is 4.096. This is greater than our radicand again. Therefore 1.6 is the new upper limit of the interval. The next approximation is 1.55. Reset all and move to home position. Input 1.55. Multiply by 1.55. The square is 2.4025. Move carriage to home position and copy the intermediate result. Reset counter and result unit. Multiply by 1.55 again. 1.55 to the power of 3 is 3.723875. This is still greater than our radicand. Therefore 1.55 is the new upper limit of the interval. The next approximation is 1.525. Reset all and move to 1. Input 1.525. Multiply by 1.525. The square is 2.325625. Move to home position and copy the intermediate result. Reset counter and result unit. Multiply by 1.525 again. The result is 3.546578. This is still greater than our radicand. Therefore 1.525 is the new upper limit of the interval. The next approximation is 1.52. Reset all and move to 1. Input 1.52. Multiply by 1.52. The square is 2.3104. Move to home position and copy the intermediate result. Reset counter and result unit. Multiply the intermediate result by 1.52 again. The cube is 3.511808. This now is less than our radicand. Therefore 1.52 is the new lower limit of the interval. The next approximation is 1.5225. Reset all and move carriage to home position again. Input 1.5225. Multiply by 1.5225. The square is 2.318000625. Move home, copy the intermediate result. Reset counter and result unit. Multiply the square value by 1.5225 again. The result is 3.52916. This is also less than our radicand. Therefore 1.5225 is the new lower limit of the interval. The next approximation is 1.523. Reset all and move to home position. Input 1.523. Multiply by 1.523. The intermediate result is 2.319529. Move to home position, copy the squared value. Reset counter and result unit. Multiply the square value by 1.523 again. The cube is 3.53264. This is still less than our radicand and therefore 1.523 is the new lower limit of the interval. The next approximation is 1.524. Reset all and move to 1. Input 1.524. Multiply by 1.524. The squared value is 2.322576. Move to home position, copy the squared value. Reset counter and result unit. Multiply the intermediate result by 1.524 again. The cube is 3.5396. This is now greater than our radicand and therefore 1.524 is the new upper limit of the interval. The next approximation is 1.5235. Reset all and move to 1. Input 1.5235. Multiply by 1.5235. The intermediate result is 2.32105225. Move to home position, copy the squared value. Reset counter and result unit. Multiply the intermediate result by 1.5235 again. The cube is 3.53612. This is now less than our radicand and therefore 1.5235 is the new lower limit of the interval. The next approximation is 1.5237. Reset all and move the carriage to home position. Input 1.5237. Multiply by 1.5237. The squared value is 2.32166169. Move to home position and copy the intermediate result to the input unit. Reset counter and result unit. Multiply the intermediate result by 1.5237 again. The result is 3.537515917. The result of our calculation is accurate to 5 digits. We are now finished. The cube root of 3.5375 is therefore approximately 1.5237. Thank you for your attention. I hope you found the video helpful.